Hello, my dear bachcho, and welcome back. I know, exams are just around the corner, but please don't worry. Today, we are going to make revising playing with numbers so much fun with a couple of simple games. Are you ready? Let's begin.
So for our first challenge, we have the yummy Idli-Vada game. Just imagine everyone sitting in a circle, just like you see here. This one simple game is going to help a really big math idea get stuck in your head for good. And that big idea is multiples.
That's right, multiples. I promise you, after we play this little game in our heads, you are going to be a master of multiples and common multiples. This is a topic that comes up in exams all the time, so let's make sure we get it right, okay?
The rules are super simple. As we count up from 1, whenever we land on a number that's a multiple of 3, like 3, 6, 9, 12, instead of saying the number, you shout idli. And whenever you land on a multiple of 5, like 5, 10, or 20, you shout vada. See? Easy, right?
But now, here comes the most exciting part. What do you think happens for a number that's a multiple of 3 and a multiple of 5? For those special numbers, you have to shout Idli-Vada. These, my dear bachcho, are what we call common multiples.
And look at this Venn diagram. It shows it just perfectly. The circle on the left, that has our idli numbers, all the multiples of 3. The one on the right has our vada numbers, all the multiples of 5. And right there in the middle where the two circles overlap, those are our Idli-Vada numbers, the common multiples, like 15, 30, and 45.
All right, fantastic. Now on to our second game, Jumpy's Treasure Hunt. This time, we're on the hunt for another really important idea in maths, factors. And Jumpy the Frog needs our help to understand factors so he can get his treasure.
So what in the world is a factor? Well, think of it like this. If the treasure is waiting on number 24, a factor is any jump size that Jumpy can take to land exactly on 24 without going past it. So jumps of size 1, 2, 3, 4, 6, 8, 12, and even a big jump of 24 will all win him the prize. These are the factors of 24, because they divide 24 exactly.
Ooh, now for a tricky little twist. What if someone puts out 2 treasures, one on number 14 and another on number 36? Now Jumpy has to pick just one jump size that will land him on both treasure spots. How is he going to do that? This brings us to our next big idea. He has to find the common factors. Look here. On the left, we have all the possible jump sizes, the factors for 14. And on the right, we have all the factors for 36. Now just look at both lists. Which numbers are in both? That's right, only 1 and 2. This means that only a jump size of 1 or 2 will let Jumpy land on both treasures. These are the common factors.
Okay, now that we're clear on multiples and factors, let's talk about the absolute superstars of the number world, prime numbers. You can think of them as the basic building blocks, kind of like the atoms that make up all the other numbers. They are so important.
So what makes a number a prime superstar? It's actually very simple. A prime number has exactly 2 factors, and only 2, the number 1 and the number itself. That's it. Take the number 7, for example. The only way you can get 7 by multiplying whole numbers is 1 times 7. You just can't break it down anymore.
And what about all the other numbers that aren't prime? Well, we call them composite numbers. They have more than 2 factors. Take 12, for example. It has so many factors, 1, 2, 3, 4, 6, and 12. So if a number isn't prime, it's composite. Oh, and remember this special point for your exam? The number 1 is special. It's neither prime nor composite.
So how do we find all these prime superstars? Do we have to check every single number one by one? Oh, no way. There's a beautiful ancient method for this, and it's called the Sieve of Eratosthenes. Let's use this grid from 1 to 100, and I'll show you how this cool magic trick works. It's really like a fun puzzle. First, we cross out 1 because we know it's not prime. Then we circle 2, our very first prime number. After that, we cross out all of 2's multiples, 4, 6, 8, all the way to 100. The very next number that isn't crossed out is 3, so we circle it, and then we cross out all of its multiples. We just keep doing this over and over. And in the end, all the numbers left circled are our prime superstars.
Okay, bachcho, are you ready for the ultimate math superpower? This is like a secret key that can unlock so many difficult problems, and it's called prime factorization. Now, this is a part you really need to master for your exams.
So how does this superpower work? Let's take the number 56. First, as step 1 shows, we can break it into any two factors, like 8 times 7. Now, 7 is a prime superstar, so we can stop with that branch. But 8 is composite, so we have to break it down more. In step 2, we break 8 into 4 times 2. Great! 2 is prime. Then in step 3, we break down the 4 into 2 times 2. And now look, we're only left with prime numbers. We just collect them all, and there's our answer. 56 equals 2 times 2 times 2 times 7.
And here is the truly magical part. Let's take the number 36. You could start breaking it down as 2 times 18, or maybe 3 times 12, or even 4 times 9. It doesn't matter how you start. This is the amazing thing. You will always end up with the exact same group of prime factors. For 36, it's always 2 2s and 2 3s. It's like every number has its own unique prime factor fingerprint.
All right, we are in the final stretch now. I'm going to give you some amazing shortcuts, some secret tricks that will help you solve problems super fast in the exam hall. These are the divisibility tests.
Now this slide is your best friend for revision. I would even take a screenshot of this. These tricks let you quickly check for divisibility without doing any long division. The easiest ones just need you to look at the last digit. If it's an even number, it's divisible by 2. If it's a 0 or 5, it's divisible by 5. And if it's a 0, divisible by 10. The rules for 4 and 8 are almost the same. For 4, check if the last 2 digits can be divided by 4. For 8, you check the last 3 digits. These shortcuts are going to save you so much time.
So let's do a super quick recap. Here are the exam superpowers we have unlocked today. You now understand multiples, thanks to our Idli-Vada game. You know that factors are Jumpy's magic jump sizes. You know prime numbers are the superstars. You can find any number's secret code with prime factorization. And you have all the divisibility shortcuts to be extra fast. You are so well prepared.
Before you go, I have a little brain teaser for you. A perfect number is one where all of its factors, except the number itself, add up to that number. For example, 28 is a perfect number. But can you find the perfect number that is smaller than 10? Give it a little thought. All the very best for your exams, my bachon. Study hard, and I just know you will all do brilliantly. Goodbye for now.